Hi friends, welcome to my channel. Let's have a look at problem 697, degree of an array. This is an easy problem marked by Leetcode. However, this problem is very interesting, so we want to use dictionary to help us do the job. So here the treatments are the following. First, we're going to use the list index method to do the job. And after that, so we're going to use left-right index to do the job. First, I'll read through the statement of the problem, and then we do some analysis, and finally we share the codes. So first, the statement. Given an non-empty array of non-negative integers, nums, the degree of this array is defined as the maximum frequency of any one of its elements. Our task is to find the smallest possible length of a contiguous subarray of nums that has the same degree as nums. So here are two examples. In example 1, so we know the degree is 2, which can be the two ones or the two twos. So if we consider a subarray of 2, 2, so which has length 2, so this is the output number 2. So in example 2, so the number 2 appears 3 times, which gives us the degree. So if we want to find a subarray contains 3 twos, so this is the shortest one. So it has length 6. So this is the output 6. So before we look at the code, let's also keep aware of the constraints or additional assumptions. The length of this list nums will be in between 1 and 50,000, and the elements in the list will be an integer between 0 and 49999, right? So in particular, so all these numbers are non-negative, right? So here our treatment is the following. First, I'm going to use or practice the list index method in a straightforward way. Then we are going to use the Gantt and styling to write a left-right index solution. So as the problem is very routine, so we are going to directly do coding without walkthrough. However, we will explain the codes in detail. So with that said, let's first look at the version 1. So this version 1, so we're going to use list index method. So this is sort of verbose, but it helps us build the intuition. First, I'm going to get the length of this list. Let's call it n, right? So next, I also want to get the reverse of this nums array. So here we want to cut the head and tail before a certain key. So next, we are going to use the counter. So I can use counter collections counter, or we can use a dictionary and linear scan the nums list. So this will give us the unique numbers and their corresponding frequencies. So the degree of this list nums is actually corresponds to the maximal frequency. Let's call it maximal frequency. So it's nothing but max count values. So this way we get the degree, right? So next we want to find the shortest subarray which has the same degree, right? So for this, we can actually first initialize a result variable. So because we want to find the minimal, so we can let it to be n at the very beginning. So this is the largest possible, right? So next we are going to check for each key. So for k in count keys, or so. So here, actually we need to do another thing. So we want to find those values which have the maximal frequency. So here we can use list comprehension. So let's see, key for key frequency or value in count items if the value equals the maximal frequency, right? So next, so this, let's see, this first part is preparation. So next we can do the check. So for k in maximal case, so we would like to find the elements which is before the leftmost index of this k, and also the right of this k, and then we just subtract these two parts to get the corresponding length of the subarray. So here we can do before, which is nums index k, right? So after, so we see after the last appearance of this k, how many elements are behind. So that is reverse index k. So then we can actually update this result by max result, and the length minus the parts before this first appearance of the k, and last appearance of the k. So that is after. So this length will be the corresponding subarray length, which have the same degree as the degree of the original array. So after that, we can actually do the return. So this is a verbose solution. So we can first do a check. So wrong answer. So let's see where what's the problem. So here reverse index k. So max values. So let's see. Oh, here not max. So we're going to take min, right? So now let's check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the cases. So now let's copy this function signature and do the second solution. So in the second solution, we're going to use dictionary, and we are going to use linear scan to find for each unique values its first occurrence and last occurrence in the original list. So this way, actually, we can get the degree, and also we can get the minimal subarray, which has the same degree as the original nums. So for this, actually, we can initialize left, right, and the corresponding counting. So so we're going to use dict, so dictionary. So here, this count actually is corresponding to here, but in this way, we are going to use a linear scan. So here for I, y in enumerate nums. So what we are going to do is that if a y not in count, not in left, so let's first set the left. So in this case, so we're going to set left equals 1. So equals I. So this is the appearance. So we are recording the indices. However, for the right, in order to get the last occurrence of this x or this y, so we are going to update this once we met it, right? So we're going to do right y equals I. In either case, as long as we do the linear scan, so we're going to do the incremental counting, right? Count y equals count get y. So this get function checks that if this y does not appear in the count yet, so we're going to set its frequency to be 1. Overall, we want to increment the frequency by 1. So that's the same. So this is the first part. It actually corresponds to something like here. So what we are going to do is first let's initialize the result. I'm going to use n, the length of this nums array. And next, what we are going to do is to check the maximal frequency. So the maximal frequency is nothing but max count values. So this is actually parallel to above. So difference is that in how we get the last and first and last indices for a k which has the maximal frequency. So with that said, let's do this. So for a k in count, if count k equals the maximum frequency, Then we can update the result. So result equals min result, and the last occurrence, that is count, that is right k minus the left k. So the left k is the start index, and the right k is end index. In order to compute the length, we should compute increment add 1, right? So with that said, so we can actually return the result state. So that actually forms another format. So let's do the check. So dict has no actually values. So see here values. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the cases. So here, this is the second solution format. So, but actually we can copy this one and demonstrate that we can also iterate reversely. So here, let's call this one version 2. So I'm going to look at here. So for this, what we're going to do, so we're going to comment this out, and then we're going to iterate backwards. So for I in range n minus 1, negative 1, negative 1. Then in this case, so the corresponding number, let's call, just to make it a parallel to the above. So then what we are going to do is that if y not in right, so because we do from right to left, then we're going to set right of y equals I. So otherwise, because we want to also get the left, so each time we match a y, we are going to update its index to be I. So this way, after we finish the while loop, the left will store for the unique elements the leftmost indices. So either case, so we're going to count a y using count get a y naught and plus 1. So all the other parts are the same. So this way, actually, we know the mechanism of how we get the left indices and right indices. So we can iterate from the front to the end, or we can iterate from end to front. So as long as we understand the detail, we can control it. So this is the third version. Let's do a check. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the generic cases. So I guess that's about it for this easy problem. However, so this easy problem give us good application or use cases for using a dictionary in a more useful way. So with that said, I guess that's it for this video. Thank you.